Welcome back, everyone, to lecture 9 about the basic rules for exponents. Okay, so before I go through these examples, I just want to kind of mention some general rules to you. When you're talking about an exponent for any number, say like x cubed, that like we talked about in the last lecture, this just means x times x times x. It works that way for any positive exponent. Works for, like, I'm sorry, just repeating myself, works for any positive exponent. That'd be, or it's good to note, I don't recall if it shows up in here. I don't know if it does or not, but just some helpful thing to note too, might show up later, is that any number raised to the 0 power and exponent of 0 is going to equal 1. Anything raised to the 0 power will equal 1. And then when you're multiplying two of the same variable together with different exponents, you add the exponents together. So say you had x cubed x to the 5th, y to the 4th, y to the 6th, and you wanted to simplify that or combine those terms together, you'd add the exponents together for the similar, or for the, for the like variables. So for the x's and then for the y's. So you'd have x to the 3 plus 5, y to the 4 plus 6. So overall, you would have x to the 8th, y to the 10th. So that's how you multiply two of the same, or like the same variable together with different exponents. You just add those exponents together. And notice how I didn't cross any of these variables together or their exponents. You can only add the exponents of like variables together. You can't do it for ones that aren't the same. And then if you have an expression like this, like say a to the 4th to the 6th, when you have two exponents that are connected via parentheses like this, one's inside, one's outside, you would multiply those together. That's the same thing as saying a to the 4 times 6. That's also to say, since multiplication is commutative, it means you can switch the order of it. You could also switch the order back of this too and represent it as a to the 6th raised to the 4th power. It's the same. You're still going to get here, which would be a to the 24th. So that's how you handle if you have like two exponents connected for the same variable via parentheses. You would multiply them together. Another situation you might see is, say you have like 5a squared b cubed, all raised to the 6th power, let's say. When you see something like this exponent, this to the 6th power, has to apply to everything inside the parentheses, to every exponent inside parentheses. And it has to be multiplied to every exponent inside parentheses, even to the coefficient. So you'd have 5 to the 6th times a squared to the 6th times b cubed to the 6th. And you can't, in this case, since it's not just a single variable, you can't just interchange these. You have to actually carry this out. And it's the same convention. You multiply the exponents. 5 to the 1st times, if in the terms of 5, we have the 1st power. So 6 times 1 is 6. So this would just be 5 to the 6th. But then we'd have a to the 2 times 6, and then b to the 3 times 6 power, which overall is 5 to the 6th times a to the 12th times b to the 18th. So you'll see 3 more examples, but that's how you'd carry out multiplying, or having a whole monomial expression. This is a monomial expression raised to a raised to a power. That's why we did monomials first, because you can have monomials raised to an exponent power, and you deal with that by multiplying the exponent to all of the other exponents, including to the coefficient. Okay, so if it helps for the first one, as we saw in the squares section, this negative sign right here in front doesn't apply to the 6 to the 4th. So you can think about this like negative 1 times 6 to the 4th. So negative, then we have 6 times 6 times 6 times 6, if it helps you to see it like that. So we could think about this like negative 6 times 6 is 36 times 6 times 6. And then, we'd have 36 times 6, which is, for just the sake of time, is 216. You can check that if you'd like to. But you don't necessarily have to if you don't want to. So we have negative 216 times 6. And then up here, I guess we'll do 216 times 6. 6 times 6 is 36. Carry the 3. 6 times 1 is 6. Plus 3 is 9. 6 times 2 is 12. So we'd have all in all negative 1,296. And as you can see, raising something to a high, or to even a relatively seemingly low power like 4 can get pretty large fairly quickly. Oh, I'm sorry, my bad. One thing that I need to mention is in terms of a rule as well. This rule still applies, but if you have a fraction like 5ab squared over cd, say all raised to the 3rd power, the same kind of rule applies where you have to apply you have to multiply the exponent to all of the other exponents inside, but you also have to do the same thing for the denominator. Remember how in the last section we said that you have to apply this to the numerator and denominator? We have to do the same thing here, even though the numerator and denominator are monomials. So we'd have 5ab cubed over cd cubed. And then we'd carry out the operation the same way as we did before. Okay, so in this case, we have negative 7 s to the 4th over t all squared. So we have to apply that square to everything. And it's important to note here too, however you want to think about it, that that second power has to apply to the negative 1 and the 7, or the whole negative 7 as together. So this would be the same thing as saying negative 7 quantity squared times s to the 4 times 2 all over t to the 1 times 2. So when we simplify this, we get negative 7 times itself is positive 49. 4 times 2 is 8, so s to the 8th over 1 times 2 is 2, so t squared. So that's our final answer here. Okay, so in the next case, we can evaluate those separately, and then multiply those numbers together at the end. So we have negative 4 squared, or negative 4 times negative 4, which is positive 16. 2 cubed is 2 times 2 times 2. We know 2 times 2 is 4, and then 4 times 2 is 8. So we have 16 times 8. Excuse me, which we can do here, 16 times 8. 8 times 6 is 48. Carry the 4, 8 times 1 is 8, plus 4 is 12. So we have 128 as our final answer here. All right, number 4, it's the same convention as we applied before with number 2. we have a fraction, that cubed has to apply to the whole negative, or to that negative as well. So here we're going to have that, because the cube has to apply to everything in the numerator and the denominator. We're going to have negative 5 cubed x cubed over 3 cubed y to the 4 times 3. Okay, negative 5 cubed, if we take that over here, that would be negative 5 times negative 5 times negative 5, because it's 3 times cubed. Negative 5 times negative 5 is positive 25 times negative 5. That negative carries out. 25 times 5 is 125. So we're left with negative 125 for that exponent. 3 cubed is just 3 times 3 times 3. 3 times 3 is 9. And then 9 times 3 is 27. So the coefficient here is going to be negative 125 times x cubed over 27 y. 4 times 3 is 12. So 27y 12. And then we can't really simplify this at all because 125 and 27 don't have any common factors. So this is our final answer. It would be negative 125 x cubed over 27y to the 12th power. We can't really do anything else with that. And then what is the exponent of m to the 6th to the 8th power? So as we discussed actually right over here, this is exactly the same thing. We have a single variable raised to a power that's also raised to a power connected by parentheses. So we just multiply them together. We have m to the 6 times 8, which is m to the 48th. So the exponent is 48. And then below, it's an even simpler version. It's just the monomial that we discussed, raised to a power rather than a fraction, which is nice. It's just this, the single expression that we have to evaluate. And as such, we have to multiply that exponent to all of the other exponents in there. So this would be 2 to the 6th power, c to the 4 times 6, d to the 3 times 6. So 2 to the 6th power, we have 2 multiplied by itself 6 times. So if we do that down at the bottom, we have 2 times 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2, and then, we can combine these other ones together into 4s because we have 2 times 2 and 2 times 2. So we have 4 times 4 times 4. That'd be 4 times 4 is 16 times 4 again is 64. So 64 is our coefficient. 4 times 6 in this exponent is 24, so we have c to the 24th, and then 3 times 6 is 18, so we have d to the 18th power. And that would be our final answer. 64 is c to the 24th, d to the 8th. And that concludes our lecture here, basic exponent rules. I'm sure there'll be more to come in the future, more advanced ones, but for now, these are the basic ones. I hope this helped, and I will talk to you next time. Thank you.